Imagine a battlefield where thousands of intelligent machines think, move, and adapt together, without pilots, controllers, or constant commands. The U.S. Army robot swarm is quietly reshaping how modern operations unfold. A silent shift in the nature of power. For centuries, military power was measured by size. More soldiers, heavier weapons, faster vehicles. That logic is now giving way to a different model. Power is increasingly defined by how quickly information moves, how systems adapt, and how decisions are made at machine speed. The U.S. Army's autonomous robot swarm reflects this shift. Instead of depending on a few expensive, highly complex platforms, the focus is on deploying thousands of small drones that operate as a single, distributed intelligence. Individually, each drone is simple and expendable. Collectively, they form a system capable of behavior far more complex than the sum of its parts. This concept is inspired by nature. Ant colonies, bird flocks, and fish schools do not rely on central control. Each unit follows simple rules, yet together they respond dynamically to threats, obstacles, and opportunities. The Army's swarm applies this same principle to modern warfare, transforming how missions are planned, executed, and sustained. What a robot swarm really is. A robot swarm is not just a group of drones flying together. It is a networked system of autonomous, unmanned aerial vehicles that constantly exchange data, interpret their environment, and coordinate actions in real time. Each drone acts as both a sensor and a decision maker. Information gathered by one drone, visual data, terrain features, obstacles, or movement, is instantly shared across the swarm. This allows the entire system to react as a unified organism rather than as separate machines. There is no single point of failure. If one drone is destroyed, jammed, or runs out of power, the swarm automatically reorganizes. Roles are reassigned, coverage gaps are filled, and the mission continues. This resilience is one of the swarm's defining advantages over traditional platforms that depend on centralized control. Autonomous intelligence at the edge. At the core of the swarm is autonomy. These drones are not remotely piloted in the traditional sense. They rely on onboard artificial intelligence, sensor fusion, and edge computing to function independently. Each unit processes data locally instead of sending everything back to a command center. This allows the swarm to operate even when communication links are limited or disrupted. In environments where GPS signals are jammed or unreliable, the drones navigate using inertial systems, visual landmarks, and real-time mapping techniques such as visual SLAM. Autonomy also enables rapid adaptation. If a route becomes blocked, the swarm recalculates paths. If conditions change, mission priorities are adjusted on the fly. This ability to sense, decide, and act without human intervention is what allows swarms to function in highly contested or unpredictable environments. Battlefield logistics reimagined. One of the most practical and transformative uses of swarm technology is logistics. Supplying frontline units has always been dangerous. Convoys move slowly, require protection, and are vulnerable to ambushes, mines, and air attacks. Swarm drones offer a different approach. Instead of a single large delivery vehicle, supplies are distributed across many small drones. Ammunition, medical kits, food, water, and communication equipment can be delivered directly to precise locations. The system is inherently redundant. If several drones are lost, the remaining units compensate automatically. Deliveries still arrive, often faster than traditional methods. The drones can navigate trenches, dense terrain, and confined spaces that ground vehicles cannot reach. This capability dramatically reduces risk to personnel and ensures that supplies reach their destination even in the most hostile conditions. Mapping the battlefield in real time. Swarm drones excel at mapping and environmental awareness. Flying in coordinated formations, they can scan vast areas simultaneously, generating high-resolution, up-to-date maps of terrain and structures. This is especially valuable in environments that change rapidly: urban combat zones, damaged infrastructure, or unfamiliar landscapes. The swarm can identify safe routes, obstacles, and potential hazards for ground forces. In cities, drones can access rooftops, narrow streets, and interior spaces that are difficult or impossible for vehicles or soldiers to reach safely. The result is a constantly updated picture of the battlefield, shared instantly across units and command systems. Surveillance and intelligence collection. Beyond mapping, swarms play a critical role in surveillance and reconnaissance. Multiple drones observing the same area from different angles make concealment far more difficult. The swarm tracks movement patterns, identifies changes over time, and maintains persistent awareness of key locations. Unlike a single surveillance platform, which can be avoided or targeted, a swarm distributes observation across dozens or hundreds of units. This persistent coverage allows commanders to make faster, more informed decisions. Intelligence is no longer delayed by collection, processing, and transmission cycles. It is generated continuously and shared in real time. Operating in denied and contested environments. Modern battlefields are increasingly shaped by electronic warfare. Communication links are jammed, GPS signals are disrupted, and networks are attacked. Swarm drones are designed to operate under these conditions. Their decentralized structure means they do not rely on constant external communication. Short-range peer-to-peer links allow the swarm to maintain coordination, even when long-range connections fail. Navigation systems do not depend solely on satellite signals. Visual navigation, inertial sensors, and shared environmental models allow the drones to orient themselves and continue operating when traditional guidance systems are unavailable. This makes the swarm particularly effective in environments specifically designed to defeat conventional technology. Electronic warfare and tactical support. Swarm systems are also valuable in electronic warfare roles. Large numbers of small drones can overwhelm sensors, confuse radar systems, and create false targets. By acting as decoys, they draw attention away from manned aircraft or ground units. By saturating detection systems, they reduce the effectiveness of enemy defenses. Some drones can carry specialized payloads for signal interference or communications disruption, allowing the swarm to shape the electronic environment of the battlefield before and during operations. Precision strike and target support. While logistics and intelligence are key roles, swarms can also support offensive missions. Armed variants can conduct precision strikes against high-value targets, such as radar installations, vehicles, or communication nodes. Rather than relying on a single strike platform, the swarm approaches from multiple directions, complicating defense and increasing effectiveness. Targets can be identified, tracked, and engaged with minimal delay. Even when not directly attacking, swarms provide targeting data and real-time updates that improve the accuracy of other systems. Disaster relief and humanitarian operations. The same characteristics that make swarms effective in combat also make them invaluable in disaster response. After earthquakes, floods, or wildfires, traditional access routes are often destroyed or unsafe. Swarm drones can be deployed immediately to assess damage, map affected areas, and locate survivors. Thermal imaging and sensor systems detect heat signatures, movement, and signals from people trapped under debris or isolated in remote areas. Once locations are identified, drones deliver medical supplies, food, water, and communication devices. They operate in hazardous environments without putting rescue teams at risk and guide responders toward the most urgent needs. A system designed to evolve. One of the defining strengths of the swarm concept is adaptability. Improvements do not require replacing entire platforms. Software updates enhance behavior across the entire system instantly. As sensors improve, navigation becomes more precise. As AI models advance, coordination becomes more efficient. Each upgrade increases the swarm's effectiveness without changing its fundamental structure. This allows the system to evolve continuously, keeping pace with changing operational demands and technological progress. Technical constraints and operational challenges. Despite its advantages, the swarm is not without limitations. Battery life restricts endurance, requiring careful mission planning or staged operations. Payload capacity is limited, meaning heavy supplies must be distributed across many units. Coordinating very large swarms demands advanced algorithms to prevent interference and maintain efficiency. Harsh weather conditions can also affect performance. particularly for small aerial platforms. These challenges are active areas of development, with ongoing work focused on improving power systems, coordination software, and resilience. A new foundation for future operations. The U.S. Army's robot swarm is more than a new tool. It represents a foundational change in how complex missions are approached. By replacing centralized control with distributed intelligence, the swarm introduces a system that is faster, more resilient, and more adaptable than traditional platforms. Whether delivering supplies, mapping terrain, gathering intelligence, supporting tactical operations, or responding to disasters, the swarm operates as a unified, autonomous force. As technology advances, these systems will only become more capable. What is emerging is not just a new weapon or vehicle, but a new way of thinking about coordination, decision-making, and action in complex environments. One where thousands of autonomous machines move together, think together, and redefine what coordinated power looks like in the modern world. If this revelation changed how you see warfare today, like, share, and subscribe to stay informed as it unfolds.